Hello everyone, in this lecture we are going to talk about how to determine the moment of inertia in the y direction for right angle triangle. We have our triangle ABC with base equal to B and height equal to H, and we are going to use this time vertical strip with width equal to dx, height equal to y, and this strip at a distance equal to x from the y-axis and x-axis. For the x-axis and y-axis, they are intersecting at the left corner of the triangle. Again, our expression of the line BC is y minus h over b multiplied by x plus h. For the vertical strip, we have dA equal to the width, which is dx multiplied by y, and we are going to integrate from x equal to 0 to x equal to b. We are going to substitute the y value by writing y equal to minus hx over b plus h. Our dA is y multiplied by dx, so we are going to multiply this value minus h by x over b plus h by the dx, and for our iy we are going again to multiply this area dA by the horizontal distance squared, which is x squared, and we are going to integrate it. So the iy capital equal to the integration from 0 to b of dA multiplied by x squared. Our dA minus hx over b plus h dx will multiply by x squared, and we will get h out. So we have integration from 0 to b of h multiplied by minus x cubed over b dx plus x squared dx inside bracket. After the integration, we have the integration of minus x cubed over b is minus x to the 4 divided by 4, and for the integration of x squared dx is x cubed over 3. Substituting from 0 to b, and we get h out, so we have iy equal to h multiplied by x to the 4 divided by 4b multiplied by minus 1 plus x cubed over 3, which will give us h open bracket b to the 4 over 4 to the b plus b to the 3 divided by 3. When we use denominator as 12b, so we'll multiply here by 3. You have minus 3b to the 4 plus 4b to the power of 4. 4b to the 4 minus 3b to the 4 is 1 hb to the 4 over 12b multiplied by h. So we have hb cubed over 12. In order to get the expression iy for the CG, we are going to subtract that value by the multiplication of the area to the x bar squared. Our area is 1/2 bh, and our x bar is b over 3. We are going to square it. It will become b squared over 9. So b squared over 9 multiplied by bh over 2 will multiply by minus sign, and we are going to add it to hb cubed over 12. At the end, we are getting an expression of hb cubed over 18 multiplied by 1.5 minus 1, which will be hb cubed over 36. The radius of gyration we can get from the expression of k squared y at g equal to hb cubed over 36 divided by the area, which is 1/2 bh. So we have k squared y at g is b squared over 18. Taking the square root, we get the radius of gyration equal to b over the square root of 3 b over 3 multiplied by 1 over the square root of 2. Now we are going to move to new item, which is the polar moment of inertia. The polar moment of inertia we can get by adding the Ix plus the Iy for the two axes x and y at the corner A. Before we have estimated that Ix equal to bh cubed over 12 and the Iy equal to hb cubed over 12. Adding them together, we will get G naught, which is bh cubed over 12 plus hb cubed over 12, taking bh as a common factor out. So we open one bracket, h squared plus b squared over 12. While if we want to get the same expression, but this time for the polar moment of inertia at the CG, we have x dash and y dash intersecting at the CG, apart by distance b over 3 from the y-axis for the x direction, and h over 3 from the x-axis. And we have before proved that Ixg and Iyg equal to bh cubed over 36 and hb cubed over 36. Adding them together, the G naught Og equal to bh h squared plus b squared divided by 36. So at the end we can get the k square or radius of gyration for the polar radius of gyration, taking j naught cg divided by the area. We get bh multiplied by h squared plus b squared over 36 divided by the area, which is 1/2 bh. We have k squared naught cg equal to the h squared plus b squared divided by 18. Thanks a lot and see you. Goodbye.